Upwards. Okay, so it's the last section for test one. Algebra of functions. Also in your, the OneNote stuff. Put in the formulas, put in some examples. Well, I'll have you do these in a moment. Also have some stuff I'm gonna give you. But first, just talk about the basics. So, very straightforward. It's using symbols, right? The F plus G, F minus G. Right here. All it is just do them separately, then add them together. So find out what the F is, find out what the G is, then add them together. Find out what the R is, okay? Multiply, divide. Super straightforward, but there's a little more depth, but in essence, it's all it is. Like, for example, right here, first we're testing you to see if you remember what it means to be negative, what it means to plug in -3. Right? So graphically, F is the like, oh, here it is. Okay. So F is that guy. So plugging -3 would be your output, right? So just plug in what you guys think. Move it up in a second. Go. Plug in -3.
So would it be in one?
It looks like it's gonna be either 1 or 10. Let's see.
Oh, no, because x squared. Yeah, no, it's not. It's a positive 9. Oh, no, yeah, the other one's positive.
That would be plug it in for all the x's, right? So 9. Did I forget something?
Yeah, the 3.
That's like 19.
Yeah,
So the -3x is gonna be a -3 and then parentheses another -3, right?
Yeah, so you're replacing all the x's with -3. That's speed input matrix. We did that before, remember?
yeah.
So square it, get a 9. -3 times -3 is another positive 9.
Yeah,
Plus
that's where I made my mistake. That -3 parentheses -3 was a positive 9, not a -9.
Yeah, be careful. You're right. It's always best to just write it out.
Right, right.
Just to see. I thought it was at first glance like that 10, like no, it's 19. So make sure you're able to plug it in because that's what you're gonna have to do to get to. Fine. So first find those two. Now let me move these. So, yeah, remember, this means for number 5. Plug in separate, and it's a fact. So what is -8 going to here? Minus what is -8 going into the G. That's all you're doing.
Oh.
So for the F part, you'll have.
Take the final answer and subtract it.
Pretty much, it's one way to do it, separately. And then just subtract. You have doing it all together just because I don't have space.
I can understand.
So at -8 will be the result. Then I'm gonna minus whatever result I get from G. So G is the square root up here. So that would be 8 minus 8, right? Negative, yes. plug in this is what they went in. Right. Okay, so this would become 4, right?
Right.
-3 times -8. What's that gonna be? Positive and 20. 8 minus minus, that would be.
Should be the -4, right? Square root of 6
Yeah, but if your function was more complicated. First, figure that out, and then do the minus.
Okay.
Okay, so like, let's say there was like 3 terms in there, like, it look like this one. Like 3 different terms. That result would then become 3 4 and then be transferred to all 3. Okay, just be careful. But here it didn't matter, just one piece.
So that's positive 16 or negative?
In here, it's, this becomes a positive 8, so it's 8 plus 8. Square root of 16 is 4, but the negative is waiting for you. So it'll come out as a -4. So yeah, 64 plus 24 plus 1, what is it? 89, is that right? Minus the 4. So the result of this guy is 89, result of this is 4. So this is then you see that what we're doing, right? Scroll up to the top, the formula just telling me to plug them in and then add them together.
Oh,
That's the minus 1.
you subtracted 4 because that's the square root of 16, right?
Yeah. So the first 3 are stuff we've done before. First 4. 5 and 6 is the new stuff. They just want you to practice so you remember. Okay. Does the general idea make sense?
It's just different functions.
So I see where you got the F is -8 and G is -8. So the next line. 8, -8 squared is,
64.
but I mean. How did you get the -8 squared?
Oh, so F is right here.
Okay,
-8 is going in here.
okay,
So this is the output of your F.
okay,
So I'm plugging in the -8 into these 2 X's.
okay.
Plug into this X and that X. To the same time. Here.
Right,
So the final answer would be 85? Just straight up?
Yes.
Okay.
The actual answer that goes into the homework, yeah.
Okay, that's like the
This
final.
this is what I want to see on the test.
Right.
The answer doesn't matter.
I just want to know how you pose it.
Gotcha. But yeah, you would just, the ending results, right, is the output is the answer. Okay, just like this one is just 19.
Yeah.
Let's try
Not bad.
6. You guys have any questions on 5? Okay,
My thing was just the square root. They're like finding the square root of 2 of the same numbers. So like, what if there are different numbers?
which one? What?
Like the square root had the 8 and then the 8 in it?
But you'll always combine along with the numbers.
Okay, so they just combine, that's it.
Yeah, so 8 minus 8.
Okay.
Okay.
Okay,
Yeah, this is really 8 plus 8.
right.
Yeah, let's try 6. So what does that mean? P times H equals 0. That'd be
So you multiply them when you got both answers.
Yeah,
Together.
find the zero part, find the H part, multiply them together. The G of zero. This one.
Every time you input the number that they give you, you gotta put in parentheses. Right?
So one more time.
So every time like they give you like zero and this is the number they give us, every time we input it for like, for X. Or whatever, it has to be in parentheses, right?
Yeah, this means your input this number into it,
Yes,
and this is saying input it into the product of the two functions.
right.
So G of zero will be square root of H minus zero times H of zero. 2 over 0 plus 1, right?
But I was asking like, are you supposed to put parentheses around that number every time?
You don't have to, but I do it so you can see what was the input. Also, sometimes like this one, right? Had a negative order there, so it helped to have parentheses showing two negatives.
Okay,
So I would say, yeah, put it up every single time, even if it doesn't help. But no, you don't have to. This reduces, right? And you would get 4/2. Let's skip this up here, but does the main idea make sense? Move on. You guys have any questions on 5 or 6?
It is like 2 square root 2, right?
Oh,
Is that? Right,
so it's square root of 8 times 2/1.
yeah, but the square root of. It is,
This one reduces to
yes,
2/2,
Mhm.
and then you have times 2.
yes,
I think it gives you 4/2, right?
yes.
You see it?
Mhm, that was it.
So this guy has a factor of 4.
Yeah, okay, so you reduce it.
So 2 times 4, 4 comes out here, and that 2 is waiting for you. 2 times 2 gives you here. That was a step. That's good. Moving on. Evaluate and write the domain in integral notation. So there's some extra notes. Basically, when you add or subtract any of the functions, the domain of both will be the intersection of each domain, but usually it doesn't really change except for division. But that's. We don't have to write so much. I have to remember what domain means.
X, right?
Yeah, it's really the X.
Like the lowest and the highest point.
So it's basically all the inputs of your function, like all the X values. If you have the parents, you can kind of see what the shapes are going to be and what the domains are going to be. So the best way to think about it is, let's look at the easy one first, a line function. Is there any issues with plugging in any specific X? Like, can I add 4 to anything? Okay, that's what the function does. T adds 4. Is there a number that you can choose for X where you can't add 4? Add 4 to anything, right?
Yeah.
So the domain could be anything. If you graphed it, you would see it hits the line. The parabola, it hits everything. So if you graphed it, you would see it. Also, you can square whatever you want. You can add 3 to anything. Doesn't matter. So the domain for these two are all real numbers. This one has an obvious problem, right?
Oh, okay.
S is the only one that's for sure there's an issue. What can I not use in S? The S function.
Like 1, right?
1's okay. 1
Or
or 0.
0.
1. 0 is a problem. You can't divide by 0.
Right.
So you'd have to exclude it. So domain for each one.
So it's like it's a real question. It's like if it's possible.
So it's gonna be everything except 0. So remember we said divide everything below all the way to 0. So don't include it. Then everything after 0. So parentheses, I don't include that spot. So visually, that would be, right, you have a whole at 0. Everything over here is fine. Everything over here is fine to input. So you would create an interval for this part, interval for that part. And in the union symbol to combine them together. Okay. These two are just domain. Domain is every all of number, so it doesn't matter. So once you have all of them, you can answer these questions. This one, S, T, right? And so all real numbers, so just infinity, negative infinity, infinity. Similarly, made for R. Same deal. If you're ever unsure, either graph it or try to find problems with the inputs.
Right.
Okay, but once you have these, then you can start answering the question that says, if I were to find a new function by subtracting them, or dividing them, or multiplying them, do I create a new restriction? Like this is a new problem up here. So you just do it in general, right? So R minus T, right here, right? R minus T. So this means
So it's still the same.
just subtract them in general. So there's nothing going in.
But you're subtracting the domain.
Subtracting the functions themselves,
Oh,
which may change the domain.
oh, so right now they're real numbers, and once you do that, you subtract them from each other, then it might change.
Yeah, because if one of them has a problem, then this new function will have a problem too. If neither have problems, then the difference will make a difference.
Okay.
So R minus T.
Finding them.
So there's my R, my T.
Why you put the T in parentheses?
Because it's minus the entire T function, so everything will get a minus, so see how it all switches. But the formulas I wanted to give you with the notes basically says if there's no problems to begin with, the plus minus times whatever will not have an issue either, so the domain will be the same thing. Okay, so the domain for R minus T will be the same domain as the combination of R and T together. But since R and T was everything, you combine everything together, it's still everything, right? So here's the evaluate part right there.
That's our new function, right?
This is the new one. This is my R minus T of X. The domain doesn't change because I use two that were already infinite, so the results should still be infinite. S times T. S had an issue, so that issue is passed on to this product. Like we said, S could not be 0, so this domain will be the same. Even though T was everything, S wasn't. So once it's together, then this has the same problem. So it kind of like inherits the problem. They both had restrictions. Then you would have the same restriction for both. Now, I'll give you some notes on this. First is do the algebra. This means S times D, which means 2 over X. See how the same issue is still there. The product didn't change anything.
So is it only division that you're really gonna have any kind of issue?
Division is the only.
What about subtraction?
Let me write the formula page at a time, but
It's only gonna be 0.
we'll get back to that in just a second. What do you think? What do you domain part two? How to divide it or that way? For plus G minus G. So if the domain of F is the set A, and the domain G is the set B, then following would be true. 1. Domain of F plus G is the intersection of A and B. The rest will be the same except for division. Right. So it is the intersection, but also. Plain English and, all language. So all of them have the same domain, so basically, if you find the domain of one of them, or of both of them, and you add them together, then whatever they have in common is the new domain. That's it. The only one you have to watch out for is if you're dividing them. Make sure you also exclude whatever makes the bottom zero. Okay, that's probably already included in here, but just in case, keep an eye on it. Okay. So that's the, why that's not in the notes, but it should be. But I made a format page here for this section. So. Domain for the difference would just be all real numbers for this guy. Right? We said the domain will be. Yeah. Here it is. So the name would just be these together. For 8. For 10, it'll be the domain of these two together. So it'll be the same. So what do these two have in common? Or S and T?
Is infinity.
Like, or the overlap, right? This is everything. This is everything except 0, so they overlap everywhere except 0. So you would choose this one. So this domain would be for S times T. So right here, you'd say. This one. Yeah, it's this. It just so happens it's the same thing.
Yeah.
So if you were to take the domain of S, domain of T, and see where they have in common, well, it's just this. It's right here. Not so it'd be the same thing. Does that make sense or no? Is that weird?
Can you like give an example? It's like 9 an example of where they're different.
Well,
It's they're all dark and everything that's matching.
so let's look at this graph both, right? Boom it down. So we said for S, it was everything, right? No. S of T domain. Visually, we said. What's this? And everything over here. And over there. For T. T domain being everything, 0, right, everything. Everything is cool. So the domain for T is all real numbers. The domain for S is everything except 0. So they have everything in common except 0, right? Because this one doesn't. This one includes it, but this one doesn't.
So basically just a gap. Right. It stops at 0 and then continues back from 0.
Yeah, it just jumps over it because I can't. Everything close to 0 is cool. And over here, everything is cool. So together, if you combine the sets, right? Question becomes intersection, that symbol I used earlier means what they have in common. So we have in common everything except zero, so this one has not doesn't. That's what we said, well, the domain turns out to be this one. You can also see it right here.
Right.
The new function we created still in common with zero. So I can't plug it in. Couldn't plug it in to the S, I can't plug it into the U. Okay. Does that make sense?
Yeah, sure. So like if now the equation were like to be. Because, you know, on one of them, it has like R over T like divided. So once you divide them from each other. In the end, right?
Yeah.
Does that make a difference?
If you divide them, R and T,
Those are both good, like those are.
yeah. So you have everything in common, so
Yeah.
it would be this, it'd be all real numbers, except the number that makes the bottom zero. Because once we do it, right? We have x squared plus 3 on top. So I'm just dividing them. I cannot use -4, correct? So plug in -4 makes the bottom 0. So together they have everything in common, but I can't use this. So the domain would be everything except -4. Have another count. Like the 0, same thing, skip the -4. So you should be able to spot it in the result. But theoretically, we said the form that's said if you know both of them, both domains, domain of F is A and the domain of G is B, if I add them together, then the domain would just be what we have in common. Or all of them. Fourth one is you just cannot have any x that make the bottom 0. So right now, we cannot have -4, so it's excluded.
So what if those flip? What if T was on top and R was on bottom?
That one wouldn't have any problems.
That would be okay. Because since 4 is a larger number, it's on bottom. That doesn't work, right?
If, well, the problem is if you plug in a -4, it turns to 0, right? But if this was on the bottom, this can never be 0, the result. Like, is there a number that you can square and make 3 turn into a 0?
0.
If you plug in 0, you get 3, right? 0 squared plus 3. If you plug in -3, you get 9 plus 3. So no matter what, it keeps coming out positive. So there's no number you can choose that would make this cancel, to make this part 0. So if this is on the bottom, the domain would be this.
Now, if the square wasn't there, then you would have it, you can't have a -3.
Yeah, the square was not there, so the -3 would be a number you'd have to exclude. And you'd exclude it like this, just create an integral all the way up until that point, but don't include it, put it in parentheses. Everything after that point, like this, using your interval notation. Okay. The hardest part is the domain questions. The algebra itself wasn't too bad, all I did was just divide it.
That's it.
Over here, S times T. Nothing to do, I could distribute 2, I guess. This one, just subtract 2. We get there. Just this domain part. If there's an interval notation, and if they do ask about domain, what I recommend is find the domain of each one separately and then do it, or once you do the algebra, look at it and see is there any problems with the results. Here there is no issue, so the domain should be all the numbers. Here we have an issue that appeared after I did the algebra. Because by themselves they're fine, right? When you divided it, you can't have -4. Over here, this came with a problem of its own. When you combine them together, it kept that issue. So the domain stayed the same as the one that had that division by 0 problem. See what I'm saying?
Yeah.
And we'll do something in a minute together. How about a worksheet that we're working on together, get more understanding of this one. The next thing I need to talk about is composition. See a little tiny circle. That means that- oh, couple of these and then some worksheets together. A little circle means compose. So F composed with G, all that means is you're plugging in the G function inside the F. So right here, there's the G, that's gonna go into this. All this is. So here, we're saying F, little circle, F composed with G and X. That means plug in the G into the X. To the X, sorry. So F of 5x plus 4. That makes sense? That's what the G is. Just
So you
put it
plug
in.
in the G into the X.
Yeah, so all the X's are gonna receive that G.
The whole thing.
Yeah, the whole thing is gonna go in there and there.
And then they're gonna get multiplied.
Yeah, then all the algebra should be done. Life size.
Right.
So there's the first one, x squared, minus the 3 times that G function. That makes sense though, what you're asking. We're just inputting a function and then dealing with the algebra. That's all we do. Just make sure you know which one's going into what. See how this one's backwards?
Do the other way around.
Yeah.
So then it would be G and you input the F.
Right, this is G of F. Which means G will receive all that. Right. Then that becomes, what does G do? G is multiplied by 5 and algebra. That's what the G does. So multiply by 5 on the inputs. Add 4. But then you just do your output, just like this. Does the main idea make sense?
Good.
Where you get that five from?
Oh, it's right there, 5 times x. So 5 times.
Oh, okay, now I see it, yeah, I didn't see it before. The whole thing is in between it and the X.
Yeah, like
Got it.
if I had F of 2, you have a 2 there, but now we have G of,
Yeah, no, I see it now, I didn't see it before, I was like, what the hell is that?
it's garbage.
But I see, yeah, okay.
So let's do your algebra here. This would be. Wanted to see the step limit on. When you FOIL this out, you should get 3 terms. Well, you'll get 4, and then you'll have the inner ones combined. So you should be 40.
Yeah.
I use the formula to skip the FOIL thing. Is that okay, or you guys want to see the multiplication? Square this, you're gonna get 3 terms. It's 5x plus 4 times 5x plus 4.
Yeah.
Should be 3, you get this, and the 1 right.
So you gotta do all the FOIL just for that part?
Yeah, you have to multiply. So I skipped that step, you got to here.
And you just did it in your head?
I use the formula because I don't want to do it. Doing it like, a long way like this.
That's how I do it.
I like it,
But,
but this, I'll show real quick, but I'm gonna erase it real fast. Right, 5 times x.
yeah, right.
I'll do this one, I'll show. 5 times the other one. 4 times that. 4 times 4. All this eventually becomes added 40. Right. Not about that, Mike.
No way.
That's a lot of mathematicians want to do is. Great formulas and shortcuts so we can work less. Right? That's just what we try to do. Want to work less.
I work hard, not smart.
All right. This was the only. This right. But anytime you have a question about algebra, I'll show you. Not a big deal. Don't be afraid to ask me. So these do combine. It's not a space. 40 minus 15.
25.
16 minus 12 plus 1.
5.
So you gotta do it all the way until it's one number, or you leave it as like that final
Well, it's
equation?
homework to know want this.
Okay, that is like
You're gonna put this at
the evaluated form or simplified.
yeah, simplify as far as you can. I mean, I would give you half the credit if you showed me this. At least that shows me you understand what you do. But you mess up on the output. You just give me that, then it's probably not gonna give you anything. Is there any questions on 11? Does that make sense? So F and G is gonna be the same thing over and over again, it's just on the homework, they're gonna change the functions. That's it. Okay. That's cool on 11. let's do it visually. Do 13 and then we'll go to the graph. And yeah, maybe that's about it. Here, there, it's the same deal, but you're plugging in another. The difference. Remember the formula, right? We said this means f of g. Let's have an x, I have 9. So plug in 9 into g. See what the result is.
I gotta throw a 9 in there.
Yeah, so before we did it in general. Now we're doing it as a specific number. You see the difference? Because here we had an x earlier. We just plug in the whole function. But now we're saying, well, what happens at 9, not just general x? Before we'd have the 2x minus 8 right there, right? If this was x. So now you're getting a result. Basically what's happening is you plug in 9 into g, you get an output, and then that goes into f.
So like 2 inputs happen at one time.
Yeah, it's a function within a function.
That's what you put it in, and then you put it in, and then you go.
Yeah, pretty much. And you'll see it better when we show the graphs. It's exactly what's happening. So 18 minus 8.
Oh, then you solve it first.
Yeah, so the output of g of 9 is 10, which is then going to go into f. So f is this.
Yeah.
Plug in 10.
Now I'm just plugging 10. Oh.
F of g of 9 is what that?
Gotcha.
That makes sense? Okay. So here's the analogy for composition. Basically, you have two functions happening at the same time. The first function takes your input, so kind of like a washing machine, washes it, gives you wet, clean clothes, and then it goes to another function, dries it for you, final output, dry and clean clothes. So it's two functions working together, being composed. Okay, so the original input, the x, is like your dirty clothes. It outputs wet. That's what the washer does. The first function of the washing machine, the second function is the dryer. So f of g, it's both at once. Does that make sense? So the final output, the first output was 10, right?
Yeah.
That 10 went in here,
Yeah.
gave you a half. So you plug in a 9. First function did stuff, gave me a 10. 10 goes in, did something else, gave me a half. Okay. Don't forget that we talked about a couple of sections ago, right? Function takes an input x, gives you an output. That's what the function does. Every function does something different. Okay.
So for
13.
I did, for a paper, I did 3/2 plugged in the 9 for the g of x. To factor 8 and So I did it in one step instead of.
You did, wait, you know, one more time, what did you do exactly?
I did 3 divided by 2 times 9 times 8 times 4. So I essentially did it in one step. And I got.
Yeah, that's fine. I mean, that's essentially what's happening.
That's how I thought you were gonna do it earlier.
That
All
is-
one big thing.
You can.
I mean, I think, I like that.
This is just to show that it's technically multi-step.
Yeah.
But the composition does it all at once for you.
Oh. So it's okay if we do it either way.
Yeah, it's okay. The other thing you could do is find the inputs first. You could say, well, what is G of F of 6 first, and do that work, and then plug it in. You do that if you want. Doesn't matter. G of F plus 6, that would be 3 over 6 minus 4. That would be 3 over 2. Now we go to the G. What does G do again?
So be -2, parentheses, 3 over 2.
2 minus 8. Do your algebra and your fraction stuff. These twos cancel. 3 minus 8. Negative. 5, right? Yes, sir. You could also find the composition of both of them and then just plug it in. They find it, is that what you're talking about? They find the actual general form, or just plugging it in all at the same time?
I was just like, zero.
So like, you could have done this, if you wanted to. Like, find the general, F of G. Once I have, because this now is plugging any number. So I could do F of G of 9, F of G of 6, just put it in here. Because that's already the result. Same thing here, once I have the final form, I can just plug wherever I want and answer any of these questions here. Right? Because this gives me a specific answer, but if I do general and then put the 9, then I'll still get it. So if you see the problem asking for a bunch of different numbers, I'll do the general first. Don't have to. Just want to work device. Do you have any questions on the composure? Plugging in numbers. What it means to compose F with G or G with F. Make sense?
So it's basically you have to find the answer to the X. And then once you do that, you plug it into what G is equal to.
Whatever coming second is the one that's going to receive X first. Get an output, and then that goes into the other. Okay. It's good. This time there's no function. We just got it. Good. Are you guys cool with the last example? So we said. So F is the blue, G is red. Remember we said, okay, this, yeah, let me transfer that over. There's a lot of ideas in this section. So. Remember we said this is F of 3 minus G of 3. So look at the graph, what's happening at 3 for half? Instead of plugging it in and doing it all the algebra, just find it. Here's 3, right? There's 4. Yeah, so this is actually 4. And what is the G doing at 3? 1, 2, 3. 1, 2, yeah, you're right. Now, we said all this means is find the outputs and subtract them, so. Cool.
So they both start at X though, right?
Yeah, this is the input. So we're always looking at the output. Right, so remember, what does a graph mean? Each of these points are being plotted to some Y.
Yeah.
Right?
Yeah.
These locations are some X, Y on the grid.
Yeah.
Okay. So here's the division. Separate that. Any questions on part A?
Again, sir, I'm so sorry.
Yeah, no worries.
How did you get to 4 for I put 3?
So F of 3, go to the blue graph,
Okay,
go to 3. 1, 2, 3. So the output is the Y value. So here is the Y. Here is the X.
okay,
This point is 3, 4. When I input 3, I get a 4. So input 3, I get a 4. When X is 3, Y is 4. That's what that makes sense. So
then
then,
the G is the red.
Yeah.
And you go to the -3?
so we go to 3, same thing. We go to where the red stops. So 1, 2, 3. That's 1, 2, 3. So this is 3, 3 right here.
And then the 4 minus 3, you're basically subtracting the Y's?
Yes, that's exactly what this is. You're subtracting the Y's. You're subtracting the outputs given some input. Okay. That's all that means. Find part B, you find the outputs and divide them. What is G of -2? Fine. F of -2. What is -4 divided by 2? Are there any questions on part B? Does it make sense? Do the same thing, but with compositions. Use the graph to help you out. Okay, so what does this mean again?
Trying to multiply those two. That we know.
This is the composed.
Oh, yeah, that's right.
G of F at 1. Thank you. So what is F of 1? Go find it. The blue.
The 2.
So the 2 is the output. What is G of 2?
Oh, divided by
4.
Yeah.
So the composition 4. Yeah, we don't have the equations anymore. We just have the graphs, but it's the same thing. It's the visual version instead of analytical. Is there any questions on C?
Basically find where F1 would be and where F1 is, you would change that for G.
Whatever that is.
Yeah, so F1 becomes 2 and that goes into G. So this is my, the 1 is my dirty clothes. F's the washing machine, G is the dryer.
Okay.
Final output, something different.
So the final answer is 4. That's what this is G is.
Final answer is 4.
Gotcha.
I think let's do this, let's do the last one, and then I think what you do, right? That's fine. So F of G of -3. It helps to write down what this means, that way I don't get it all backwards in my head. Use myself. G of -3, so what's happening at -3 for G? 4. 1, 2, 3. Right. So this becomes F of -4. So what is F doing at -4? That's like, yeah. Any question where
Wait,
these
so
numbers
you
are
found
coming?
you found the G first at -3 or F first at -3?
So always work your way out. So inside first, G of -3 is the only thing the only instructions I have. -3 is going into the G. So what does that mean? Got an output of -4. So now that's taken care of. Deal with this new input, get the final output. Just like up here. Yeah. The F took the 1, gave me a 2. G took the 2, gave me a 4. Piece by piece. It's just that I'm using a graph instead of a function. This one is composing F with itself. But before I start, are there any questions on the last 2 problems? You guys are cool? All right. All right, again. What happens to -3 for F?
Oh,
Yeah, right. So now we have a 0. What happens at F of 0? Positive. Yeah, I'll do it. What do you think questions on that out, right? F of -3 is 0. Yeah. 0 was in the F, so what's happening at F2? That's the last example we're gonna have.
Yes.
F of
-5.
which is. One.
Yeah, so now I write one down, and then I write plus, what is 0?
-5 is 140.
4, and now we add this and we find the answer. Which this, at the end is gonna look like 5.
That's what we're finding out. I need this composition first. Well, first, find it.
Now it's an add to anything.
It's not, I mean, just because, if you want, why wouldn't it be 114?
It is,
Or actually,
it is true, but that is a mix number. And most of the time, when they ask you to calculate it, they want like a function.
so basically 1/1.
Yes, and
That's why you
then.
have
This one you can
And
have
then
two, for
you have
This one has
to
English.
percent there, you multiply by 4 here, 1 and 4, and then you have 5/1. This one, this one, so, and you do the same things, with this one, and this one, and this one.
So the final answer,
one going
the
inside.
final answer would just be 5/.
Is G.
Yeah, but.
That one has no restriction.
Oh, right, no, I,
All you have to worry about is the restriction of
Yeah,
the
trying to answer.
same.
Yes, sir.
Oh, wait. Oh, this one, would it be two? Because it says, you know, that there's two lines up in, so.
Okay.
Would it be the highest number, the lowest number that I use? Fine.
For M?
Yeah, for,
So now let me show you. So how many functions do you have written?
I guess, three, right? They get you that.
Yes.
Yeah,
So now
X on the bottom.
the F is this one and this guy.
So,
So you're gonna have to use both, but depending on where your X
So-
is, then you use one or the other. For example, if you have an X that is
Is it,
between zero, yeah, you're gonna use,
oh, I use this?
yes, why? Because
The
this
view
one is the one that is
restrictions of
closed.
the composition.
On this side, it is open, so if
G
you have
had
zero. you
So
cannot find
the only
it,
restriction
zero
you have is
inside, because it's open. So the F from zero.
This is where it's at, at zero.
Originally,
Yeah,
had a
because
restriction
it's
X,
solid, right?
but this is almost like an infinite here.
Right.
So,
No, it's not infinite, but like a, because, so in the function, you cannot have one X that has two Y's. So that's why one of them is open, meaning that, F of zero is not gonna be on this segment. It's gonna be on this segment because that's where it's falls.
But if F of five, would be
Mhm.
one.
Yes, yes, because it's not open. Because look at this, so this one is not open, that means it's there.
Okay,
Like, for example, if you have this H of X, F of 5 is not there. It does not exist because it's open.
okay,
Same goes for G.
yeah, if it's open,
It's not there.
it's not there. So two is, if I had G for -5,
Yeah, it's not, you're not gonna find it.
that's not real.
so let's say,
Yeah, because it has a hole, that
You put
means
the
you don't
square
have,
root or something?
you don't have the value for it.
That's undefined.
then
You can call
X
it.
being greater than equal to 0 would be an
Okay,
extra
cool.
restriction
Thank you.
Okay, you're welcome.
other than. X. Yeah.
yeah.